So we're now deep, thick in the topic of talking about radicals and how radicals work from a variety of different perspectives. In our last class, we looked at two different aspects of how radicals work. The first one is we took a tour through the quadratic formula. The quadratic formula is our tool for solving any second degree equation if we either can't or just don't want to use factoring. We spent a lot of time working on how to factor and why we can use factoring to solve an equation. The quadratic formula will always work whether or not factoring comes through, whether we even try to factor. We can always apply the quadratic formula to a quadratic equation, so degree 2 equation. Once one side of that equation is equal to 0, we can identify the a, b, and c coefficients as respectively the quadratic, the linear, and the constant coefficient. And then just use a, b, and c in this formula. And of course the cost for entry here is remembering this formula. X equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. We took a few minutes on Wednesday of last week to walk through where that formula comes from. That's the stuff that you don't need to have in your notes or in your memory, but maybe the result, the ending formula, is the tool that you want to have in your memory bank. So that if you decide to use this, or if it is necessary to use it, then it'll be there for you. And the hardest part about the quadratic formula, next to remembering it, is actually navigating its use, and in particular, navigating the sign errors that might show up. Okay. So in the example we looked at on Wednesday, we were solving 2x squared plus 5x minus 4 is equal to 0. And the trick there is when we substitute the negative value here, negative 4, the value of c, when that gets substituted in this minus 4 times a times c term underneath the radical, we end up with a pair of negatives. 4 times 2 times negative 4, but then that's ending up getting subtracted. And so the most common place for people to flub the quadratic formula, even if you remember it correctly, is to make little sign errors, like the error we could have made here. Subtracting negative 32 is actually adding positive 32, and then we get to there. So getting a lot of practice with using the quadratic formula is a good idea because it resensitizes you to the importance of making sure that negative signs that belong to a quantity go with that quantity as you do algebra with it later on down the line. The thing we didn't talk about, but which I'm actually not going to police you on in the quadratic formula, is that sometimes in your final answers, the square roots that you end up with can be simplified a little bit further. This wasn't such an example. 57 is not a number whose square root can be simplified in any meaningful way. But there might be some examples, and if you see examples like this in the textbook, let me just talk briefly about it. Let's suppose that you got square root of 24 or something in your final answer. It turns out we can simplify the square root of 24 in kind of a nice way. How might I factor the number 24? What are some ways to break apart the number 24 into factors? 4 and 6. Sure. Yeah. And then 6 breaks apart. And 4 breaks apart. And so what we notice, very good, what we notice is that there's one factor inside of 24 which appears twice, okay, the factor 2. And what that means in particular is that I could rewrite 24, 2 times 2 times 2 times 3, underneath this radical. If I write it out in terms of its prime factorization, then what I notice is that I have a perfect square. 2 times 2, 4, is a perfect square underneath this radical. So what does that mean that I can do? It means I can split apart this radical into a product of 2, because the radical of a product is the product of radicals for reasons we're going to talk about later today. And one of these two factors I can simplify. Square root of 2 times 3, that's just the square root of 6. That's going to be some nasty number. But how can I rewrite the square root of 2 times 2? What do I get there? Yeah, there I just get 2. Why? Because on one hand, 2 times 2 is 4, and this is the square root of 4. On the other hand, and this is the more sophisticated way to think about it that's going to be useful for us today, 2 times 2 is just another way of saying 2 squared. And the entire reason in life for a square root to exist is to cancel out with a square in the exponent, right? That's the entire definition of what a square root is. It's the reason we care about square roots, or radicals in general to begin with, is that they can cancel out those powers. Right? And so if I had had a number like 24 underneath the radical, here, I could have done this process to simplify it down into 2 times the square root of 6. And that might be convenient if then it provides me with an opportunity to simplify this division here anymore in my final answer. But I'm probably not going to police that too hard on your final exams, for example, unless I specifically ask for it, and I don't plan to do that in an exam situation. But for the problems that we work on today, if something like this shows up, you may wish to try it just to get the practice on it. There's one more eventuality in the quadratic formula that we didn't get a chance to discuss. What if, when we first started working on this problem, I had actually written a different problem on the board. You can kind of see it right here that I erased a little negative sign that used to be there. Let me talk about why I changed the problem in the way that I did. So let's put that negative sign back in. And then when we solve to get a 0 on one side of the equation, this 4 here would end up becoming a positive 4. And then when we went into the quadratic formula here, we would have substituted a positive 4 for c instead of a negative 4. So the only thing in my work here that would change is that this negative 4 would now become a positive 4. And then 4 times 2 times 4 would have been 32, positive 32. And so when we did the subtraction, we wouldn't have been subtracting negative 32, we would have been subtracting 32. And 25 minus 32 is not going to give me 57, it's going to give me negative 7. And so my question is, why was I, in the moment last Wednesday, concerned that I didn't want the square root of negative 7? Can you think of a reason why? You're shaking your head. What's the problem with the square root of negative 7? We can't do it. If you pull out a calculator and type negative 7 and then hit the square root button, it's going to pop up with an error, right? Yeah, so what's the problem with the number negative 7? What kinds of numbers can we not take the square root of? Negatives. Negative numbers don't have real square roots. We could think for a moment about why that is. So maybe instead of negative 7, let's think about a slightly more straightforward example. Let's just think about negative 9. How are we to understand the square root of negative 9? This is supposed to be a number which, when I multiply it by itself, when I square it, I get the number negative 9. So this is a solution to x times x is equal to negative 9. Right? Okay, but why does that equation have no solution? What happens when I multiply a number by itself? Let's say that the number that I have here for x is a positive number. Then if x is positive, what is x times x going to be? Positive. Positive times positive, that's going to give me positive. Okay. And so I can't make a positive number's square equal to negative 9. What if x is a negative number and I multiply it by itself? Yeah, negative times negative is positive too. So even if I try to make x a negative number, there's no way I can square it and get an answer that's positive, or sorry, that's negative. The only way to get a negative number is to multiply two numbers that have opposite signs. But that's not what happens when you square a number. You only square a number, you're multiplying it by itself. So a number can't have the opposite sign of itself unless that number is 0. And if I multiply 0 by 0, I'm still not going to get a negative answer. So anytime there's a negative number underneath your square root, after your square root has been totally simplified, so we did all the arithmetic here to simplify 25 minus 32, negative 7. Once there's a negative number underneath that radical sign, the result of that square root problem is not a real number. In fact, because it's not a real number, mathematicians call it an imaginary number. That doesn't mean that it doesn't exist. It just means it's not part of the number system that we work with in this course. Right? And so depending on where you're going with the mathematics you're learning here, this might end up being important down the line for you, but most of you probably not. And so if something like this happens, what do we do? Like if I were working this problem on an exam, I ended up with a negative 7 under the radical. I'm just going to pull my ripcord on that one and just say that this quadratic equation would have no real solution. There is no real number that makes 2x squared plus 5x plus 4 equal to 0. Because any number that would make that quantity equal to 0 would have to take the form of -5 plus or minus the square root of -7 all over 4. And the square root of -7 is not real.